This project is to minimize overpassing sustainability. This overpass is located on the intersection of US 17 and SC 544 in Myrtle Beach, South Carolina. It has a budgeted cost of $380 million and has a scheduled duration of 3 years and 2 months, with it already being 1 year in construction. The following is a video. Our team used Envision to rate the project. Envision is a rating system for sustainable infrastructure. It was developed by the Institute for Sustainable Infrastructure in partnership with the Harvard Graduate School of Design. It rates energy, water, waste, transport, landscape, and information. It has 5 categories in quality of life, leadership, resource allocation, natural world, and climate and risk. See the below example. When the team used the Envision rating scale, it saw there could be an improvement in leadership and resource allocation. But there is a high score on the natural world because of an existing road already being there. Visit the below website for a more specific breakdown. How can we improve? It starts with a sustainable vision. Perhaps creating a design charrette, which in turn participants can create a concept map, and also then discover a form of biomimicry, such as water repelling off of leaves in comparison to water running into the drainage system. Can also reduce the energy output, with LED lights being installed on the overpass. While working at night, low-emission lights could be used, and a saving of 80% of energy per year during night work. We can also reduce the waste on the site. For example, in the picture shown with wick drains, at about 40 cents per vertical foot and 6 inches left above the ground, with over 5,000 installed, without 6 inches being left out of the ground, there can be a minimum savings of at least $1,000. In constructing the overpass, perhaps pervious pavement would be a good option. You could recharge the groundwater, reduce stormwater runoff, and eliminate the need for retention ponds. On the on and off ramps, perhaps even a bioretention system, which uses vegetation to remove pollutants from stormwater runoff and control the volume of flow. And this would reduce costs for filtration systems. Why not get this water that doesn't necessarily need to be treated and use it to compact this soil? In the bottom right corner, you can see wasted steel. It would be more cost effective to recycle it, which in turn reduces carbon dioxide emissions that would have been created had new steel been manufactured. As you can see in the picture, there are a lot of concrete pipes. These need to be transported a quarter of a mile away to the installation area, and with diesel gas rising up to $4 per gallon and the average front-end loader only getting around 7 miles per gallon, you can save at least $135 on the operation with a closer storage location. Imagine the savings if this was done to hundreds of operations on the project, or you can even just use an alternative fuel source. There are many other things that can be done, but it all starts with leadership and a desire to be sustainable. Now let's look at some positives. Let's look at the life cycle assessment of the waste dirt. The supply is already in the ground, so it does not need to be produced. It will be transported using trucks, but there's no manufacturing. And the use of the waste dirt is to fill in the pond, therefore no disposal is required. In the aspect of social and environmental sustainability, temporary seating is provided to motorists passing by to provide an aesthetic appeal during construction. The project also uses local resources, such as locally produced concrete only 5 miles away, and aggregate coming from the Grand Strand area. Not to mention all the contractors and subcontractors were hired within the Northeast South Carolina region. The project may not look appealing now, however, it will not only improve traffic flow, but also stimulate business around the area. This was created by Drew Pavey and
Ross Jones.
Special thanks to Dr. Lottie Klotz and John Johnson of CDM Smith.